In this video, we're going to be talking about Dalton's law. Specifically, we're going to be doing exercise 17 in your packet. So before we even start exercise 17, let's talk about what Dalton's law is. So Dalton's law tells us that if we have this container, okay, at a certain pressure, a certain temperature, a certain volume, but each of these different colored dots are a different type of gas. Well, our total pressure is equal to the pressure of each of these gases. So it's the pressure of the red plus the pressure of the orange plus the pressure of the blue gas. And the way to tell the difference between these pressures is to count the number of moles. So notice let's call each of these dots 1 mole of gas. So in this case, we have 4 moles of red. We have 3 moles of orange, and we have 1 mole of blue. Okay, and these are each different gases. So they are all of these gases, they're in the same container. So the volume for the red, orange, and blue is all the same, right? They're in the same exact box. The temperature is the same because, again, they're in the same box. And our total pressure is a combination of all of their pressures. So the red is going to have the highest total pressure because it has the most moles. The orange is going to have the second highest pressure because it has the second most moles, and the blue will have the least pressure. And each of these pressures can be determined by a mole ratio. So when we talk about a mole ratio, we are talking about how many moles of each per total. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8 total moles of gas, right? 8 moles total. So our mole ratio of red is 4/8, which is 1/2. Okay, so that's our mole ratio of red. So when we talk about what is the pressure of red, what is our red pressure right here? That is equal to the total pressure times 1/2 times our mole ratio, because the total pressure is caused. Half of the total pressure is caused by just the red gas, because half of the moles of the gas, of all of the gas, is the red gas. So our mole ratio of orange is 3/8, 3/8. So our orange pressure would be 3/8 times the total pressure, and that would give us our orange pressure. And then our blue mole ratio is 1/8. And so when we multiply that by the total pressure, that would give us our pressure of the blue. Okay, so with that in mind, exercise 17 says mixtures of helium and oxygen are used in scuba diving tanks to help prevent the bends. For a particular dive, 46 liters of helium at 25 degrees Celsius and 1 atm and 12 liters of oxygen at 25 degrees Celsius and 1 atm were pumped into a tank with a volume of 5 liters. Calculate the partial pressure of each gas and the total pressure in the tank at 25 degrees Celsius. So the first thing we need to think about is, what are we going to do, right? We need to figure out a plan. So we're told we have the volume of helium, the temperature of helium, and the pressure of helium. And we have the volume of oxygen, the temperature of oxygen, and the pressure of oxygen. So as soon as you know that you have P, V, and T, you can use the ideal gas law. So we can use these numbers to solve for our moles of helium and our moles of oxygen. We are told we want to calculate the partial pressure. Well, in order to have the partial pressure, we need the mole ratio, and we need the total pressure. And then we are also told that we need to find the total pressure in the tank, and we're given a temperature. So pressure equals nRT over V. So we have the volume. That's right there. We have the temperature. R is a constant. Moles will be our total number of moles because we're looking at P total, not just P oxygen or P of helium. So our total number of moles is going to just be found by adding our moles of helium to our moles of oxygen. And then once we have our total pressure, we'll then be able to find our partial pressures. So I want you to pause the video and I really want you to solve this on your own, and then you can continue playing the video to check your answer. So here I've plugged in all of my numbers just in regards to helium to calculate my moles of helium. And now I've done the same thing for oxygen. I've calculated my moles of oxygen. So now I am looking I'm going to solve for the total pressure in the tank first. So again, I can use the ideal gas law, but I need to use my total number of moles. So I'm going to add those moles together, and then my R is a constant. I'm told the temperature, and I'm told the volume. So go ahead and calculate your total pressure. And I've rounded to 2 significant figures because that is the minimum of significant figures I'm given. For instance, my volume is in 2, so even though my temperature has 3 significant figures, I use the least precise, so the 2 significant figures. So this shows my my total pressure, but now I need to figure out what is my partial pressure of each gas. So I'm going to start with the pressure of helium, and again, partial pressure. So the pressure of like any specific gas is the mole ratio times the total pressure. So I have my helium, so my total pressure is 12 atm, and I need to multiply it by the mole ratio, which is the number of moles of helium divided by my total number of moles. And since it's moles divided by moles, it's actually a unitless quantity because moles cancel out, so it's just a ratio. You can just have those numbers. So my partial pressure of helium is 9.5 atm. And then I can solve for my partial pressure of oxygen 2 different ways. I can think, okay, well, my total pressure of 12 atm has to equal the pressure of helium plus the pressure of oxygen. So I can do 12 minus my 9.5, or I can do my pressure of oxygen is equal to my total pressure times the mole ratio of oxygen, which is the 0.49 divided by 2.4. So you should get the same answer either way, and your partial pressure of oxygen should be 2.5 atm.